Hello students. So in this lecture we'll discuss about hidden Markov model. So before seeing this hidden Markov model, first we need to know what is meant by Markov model. So Markov model, it mainly describes the probabilistic relationship between different states. Say suppose we have a system with three states: happy, sad and angry. Then over a course of day, a person will be in a particular state, right? So he won't be in the same mood throughout the day. Say, for example, one that corresponds to their, so based on their emotion, that state will change. So person can stay in one state for several hours and then he may change to a different state. So this can be represented using a Markov model. So where we can take sequence of states where each state depends on the previous state at a particular instant of time. And coming to this, we'll take one. So we'll see how to represent these states in the form of a chain. For example, we have states like this: chain of states x1, x2, and x3. So according to the Markov property, future event, it mainly depends on the current event, but not on the any other event in the given states. Or it won't depend on any other events, the previous events. Say suppose here in our example, we have total three states, right? So x3, it depends on the previous state. So future state means here, if uh, if the states are given like this, say suppose this is represented with t and this is represented with t minus 1, and here this we are representing it with t plus 1. So this represents a future state and it represents the previous state, and this is your current state. So according to the Markov property, future event, it depends only on the current event. So what is our current event? It is x2. Whereas it won't depend on any other events like x1. So now, so suppose if the states t1, t minus 1, t plus 1, for example, if they are not given, then how to identify the events? So depending on the observable states or the evidences, we need to find the states here. So the states, for example, these are not given. Then you need to find out x1, x2, and x3 based on the observable states. So here observable states are y1, y2, and y3. So what are the hidden states here? X1, x2, and x3. Whereas this y1, y2, and y3, they are considered as observable states. And this x1, it emits signal in the form of y1. So x1 emits y1, x2 emits y2, and x3 emits y3. So these are considered as emission probabilities, whereas these are considered as transmission probabilities. And now, so here in Markov model, if y1, y2, and y3 are given, we should find out respective x1, x2, and x3. So say suppose let us consider a simple example. Assume that there are two friends, Alice and Bob, who live far apart from each other. But they'll talk together daily over the telephone about what they did that day. So Bob is only interested in three activities here. Say suppose the activities are walking, then shopping and cleaning. So I'm just writing the start word. So W represents walking, S represents shopping, and C represents cleaning his apartment. So the choice of what to do, it is mainly determined by the weather on a given day. So Alice has no definite information about the weather, but she knows general trends. So based on what Bob tells her he did each day, Alice tried to guess what the weather must have been like. So Alice believes that the weather operates as a discrete Markov chain. So there are two states here you can see in this diagram. So one is a rainy, second one is sunny. but she cannot observe them directly. So here they are hidden from her, right? So Alice, she cannot see these states directly. So on each day, there is a chance that Bob will perform one of the activities. So activities are walking, shopping, and cleaning. So since Bob tells Alice about his activities, we consider these activities as observations. And the entire system is considered as a hidden Markov model. This is just similar to your hidden Markov model, whereas the states rainy and sunny, they are treated as hidden states. So this is one best example. And let us try to understand what are the transmission probabilities, emission probabilities, everything with a second example. So this is just an intro to hidden Markov model. And now, so let us take this one. Assume that we have an imaginary friend, Lee, and during the day she can perform either of the four things. So it can be either painting, cleaning the house, biking, shopping for groceries. So these are the four activities. So we can consider them as observables. Now, from this observation sequence, we want to know whether the day has been sunny or rainy. So based on this sequence, we need to find out that. So these two states, sunny and rainy, they are going to be our hidden states. So you can see this in our diagram. So hidden states, what are the hidden states here? Sunny and rainy, right? Yes. And then what are the observables? They are paint, clean, shop, and bike. So based on the observables, we need to predict whether the day is a sunny day or rainy day. Initial probabilities. So here the likelihood that it is sunny on the first day. So initial probabilities or initial day might be a sunny day. That probability is 0.6. Whereas likelihood that it is rainy. So that probability is 0.4. So here every row of the matrix, it must add up to 1 since they represent probability. So here if you add 0.6 and 0.4, it gives you 1. So those are your initial probabilities. And now transition probability. So a matrix that represents the probability of transitioning to another state given the current state. That is nothing but transmission, right? Transition. So if the current state, for example, if the current state is sunny, then in that case, you need to find out the probability that the day after is sunny. That means today is sunny, and what is the probability that tomorrow is also sunny? So you can see, you can take it as a loop here. The probability is 0.8. And what is the probability that the day after is rainy? That means today is sunny and tomorrow is rainy. So that probability is 0.2. So assume that we are in a rainy day. And the probability that tomorrow is also rainy day. So here that is represented as loop again. So probability is 0.6. So today is a rainy day. Probability that tomorrow is sunny day. That probability is 0.4. So in this way, you can represent these probabilities in the form of a matrix. So I'll show you that. So coming to emission probabilities. So a matrix that represents the probability of seeing a specific observable given a hidden state. Say suppose if you take the same example, the probability of clean on a sunny day. So here on a sunny day, what are the chances that the sleep performs cleaning? So that chance is 0.1. So that is emission probability. And probability of clean on a rainy day. So the same cleaning, if it is a rainy day, that probability is 0.45. So like this, you need to find out emission probabilities. So these are some properties. So we just saw hidden states. The two hidden states we used are sunny and rainy. Observables are paint, clean, shop, and bike. So all these things, they should be arranged in the form of a set. Initial probabilities. So they are represented with pi, that is equal to 0.6 and 0.4. Transition probabilities, we just, so we saw that these two probabilities just now, right? Okay. So how to represent transition probability between the states? So this is the representation. So sunny followed by sunny. Probability is 0.8. Today is sunny and tomorrow is rainy. That probability is 0.2. Rainy followed by sunny day, 0.4. Rainy followed by rainy day, that is 0.6. In the same way, you can find out emission probabilities also. The chances for performing a painting activity on a sunny day is 0.4. Chances for cleaning on sunny day is 0.1. Performing shopping, activity shopping is 0.2 on sunny day. And bike or riding on a sunny day is 0.3. Similarly, we can calculate values for rainy day based on the example. So I told you that we need to arrange everything in the form of a set. So you can see hidden states, they are represented in the form of a set, sunny and rainy. Observables, again, they are represented with O, initial probabilities, transition probabilities, and emission probabilities. So we'll represent with pi, A, and B. Now say suppose the sequence is given to us like this. And the sequence is sunny followed by rainy followed by rainy followed by sunny. So this is our sequence. Now we need to calculate. Here we need to find out probability for occurrence of this sequence. So let us first represent this. Sunny is represented with E1, rainy is represented with E2. Again, rainy is represented with event E3, sunny is represented with event E4. Okay. Now, find the probability of occurrence of this sequence. So, in order to find the sequence, we need transition probabilities also, right? So, let me draw transition probabilities here. And the chances for sunny day. Sunny followed by, okay, sunny, rainy. And this is sunny, rain. So I'm just drawing the same matrix here. 0.8, this is 0.2, and this is 0.4. This is 0.6. Okay. So now our task is first find out the probability from. So let us take P of E2 given E1. Probability of occurrence of event E2 given event E1. So that means E1 is a sunny day. So what are the chances for event 2 to become a rainy day? Right? Probability of sunny after the, sorry, probability of rainy after the sunny. Okay. So this probability, so that means sunny followed by rainy. So what is the probability here? Sunny and rainy. That value is 0.2. So this is nothing but 0.2. Now we need to calculate the same for remaining sequences also. So probability of occurrence of E2, E3 and E4 after E1. So we need to find out this. So this can be written as probability of E2 given probability of E1, probability of E3 given probability of E2, E4 given E3 and multiply that complete value with initial probability of E1. So first find out probability of E2 given E1. That means sunny followed by rainy. So sunny followed by rainy. Possibility is 0.2. So this value becomes 0.2. Next, probability for rainy after rainy. So rainy sequence, we have 0.6. So multiply that with 0.6. And probability of E4 given E3. What is E3? Rainy. So sunny after rainy. So sunny after rainy. That is rainy sunny. So this value is 0.4. Initial probability of E1. So the probability of being so probability for sunny to be the first day is 0.6. So multiply all these values. So say if a sequence is given to you, then you can find it like this. What if the sequence is not given? And say suppose we need to find out probability of these 4 days. In that case, the first case or the first possibility can be either sunny or rainy. So we don't know the sequence. Second day, it can be either rainy or sunny. Third day, it can be either rainy or sunny. Fourth day, it can be sunny or rainy. So every day we have two chances. It can be either a sunny day or it can be a rainy day. So like this, you can calculate for n number of days. So here I'm just taking only 4. So what will be the probability here? So here the chances are 2, right? So it can be either sunny or rainy. So that value becomes 2. And how many events we considered here? 4. So this becomes 2 power 4. That means there are total 16 sequences. So 16 sequences are possible for this question for the next 4 days. So in this way, you need to calculate probability for the given question. So this is all about hidden Markov model. So in our next lecture, we can find out example. So how to solve POS tagging using hidden Markov model. Thank you.